Okay, we are going to talk about the shapes of molecules, which you need to know. Now, most molecules that we think of, they've got 8 electrons in their outer shell. Not all of them. We've seen some, like from period 3, like sulfur and phosphorus and chlorine. They're allowed to have more than 8 electrons in their outer shell, but a lot of them, we're talking about 8 electrons in their outer shell. So that means you have got 4 pairs, yeah, because electrons always pair up in the orbitals, don't they? So they can either be bonding pairs or they can be lone pairs. So let's have a think about methane. Now, when you're doing this topic, I think it's always important to always draw a dot cross diagram, and if it's an exam, always just draw it, in the margin, cross it out or something, but just so you don't forget about electrons. Let's think about methane. Right, so carbon's got 4 electrons out of shell, so you're going to have you're going to have a dot from the carbon and a cross from the hydrogen, dot, across, dot and across, dot and across. Carbon has got 4 electrons of its own. We've drawn 4 dots, so that means there are no lone pairs in that case. It's very easy to forget about the lone pairs sometimes, so that's why it's important to draw a dot cross diagram. So what we've got there is we have got 4 bonding pairs. Now, I've mentioned already that those they'll try and get as far away from each other as possible, and the way they can do that is by forming a regular tetrahedron. So if I draw, we've got carbon at the center. We've got one hydrogen here sticking up. We've got another hydrogen. No, those carbons, those flat lines shows that they're all in the same plane. That hydrogen, that carbon, and that hydrogen would all fit on a flat piece of paper, but it's not a flat molecule. We have got one hydrogen coming out towards us, and the conventional way of doing that is to draw a wedge. And you've got another hydrogen going back into the plane of the screen, and the conventional way of drawing that is a dotted line. Okay, so we've got 4 bonding pairs. Now, the angle between each of those carbons, it forms a hydrogen, sorry, it's the corner of a regular tetrahedron. Okay. Okay, so that means that angle there, and you can work it out, and you don't need to be able to work it out, but it is 109.5 degrees. So it's bigger than a right angle, and if you think about the way we draw methane normally, we draw it flat. Well, those bond angles look like they're 90, don't they? Well, 109 is bigger than 90, so that's why it does it, because they can get away. These don't forget, are molecular orbitals with negatively charged electrons, and they're trying to get as far away from each other as possible, and the way they can do that is by forming this 109.5 bond angle and tetrahedral shape. They wouldn't do this because it'd only be 90 degrees, and that's why methane is not a flat molecule. Okay, so right, so that is when we have got 4 bonding pairs. Now let's go over to so we're thinking about carbon, nitrogen, oxygen, okay, and then of course fluorine and neon, top end of the periodic table. Okay, let's do nitrogen next. Okay, what compound does nitrogen form with hydrogen? Well, it forms ammonia, NH3. Let's draw a dot cross diagram. So we have dot cross, dot cross. Now nitrogen is in group 5. I've only drawn 3 electrons, so it needs 2 more, a lone pair there. And that's why it's important to draw the dot cross diagram, because then we remind ourselves that yes, there's a lone pair to think about. Right, that's going to be a very similar shape to this. So what happens is, right, that nitrogen and that hydrogen in the same plane of the paper as each other. This hydrogen is coming out to you like a wedge. That hydrogen is going back into the computer screen. And here we're going to have a lone pair. Now I'm going to draw the lone pair in. Yeah. And don't forget, lone pairs are more of a bulbous shape, aren't they, than bonding pairs? You know, bonding pair would be more like a sausage like that. This is more bulbous. Now that has an effect on these bond angles because let's think about that angle there. Is this lone pair causes more repulsion and it pushes down those a little bit more than you'd expect because of its shape. And so this bond angle isn't 109.5. It's usually quoted, it's a bit smaller. It's usually quoted as 107.5 degrees. And of course, that bond there is exactly the same. And the bond around the back between this hydrogen and that dotted line, that's 107.5 degrees as well. Okay, so that is the case when we have got, here we've got three, and we'll summarize this information. We've got three bonding pairs and we've got one lone pair. Now, can you think we've got four bonding pairs up there. We've got three bonding pairs and one lone pair. Can you think of a molecule which has got two bonding pairs and two lone pairs? Well, we're talking about hydrogen bonding recently. So how about H2o? Water. Okay, so water has got, let's draw water. Dot cross diagram. To remind ourselves, there are lone pairs there. We've got a dot and a cross, a dot and a cross. Now, oxygen in group 6, I've only drawn two, so that means we've got two lone pairs to think about. So if you draw a water molecule, let's adapt this, what's going on here. So you draw, here's your oxygen, there's your hydrogen, so they're in the same plane, and then you've got one water molecule coming out towards you there. Now this thing that should be going back in, that's going to be a lone pair, isn't it? So maybe draw that in a different color. That's a lone pair. And we've also got another lone pair up there. Sort of. Okay, so that means you've got two lone pairs, and these are both, you know, they're more of a bulbous shape than the bonding pairs, which are more sausage shaped. And so they cause even more repulsion. So that bond angle, it's not 109.5, like that one. It's not 107.5, it's even smaller. It's usually quoted as being 104.5. And that is because you get more repulsion between the lone pairs than you do between the bonding pairs. So water is that is the bond angle there. Of course, I could draw all those three are in the same plane. I don't really have to draw one as a wedge, do I? Because whenever you have three things, they're always got to fit onto a flat piece of paper somehow. But I'll leave that like that. So let's just talk about the shapes of these, right? So if anyone asks you about the shape of this molecule, you would say this is a tetrahedron. Tetrahedral. That's the shape. This one, it can either be called distorted tetrahedral, which I like because that's more descriptive. But usually it's called Trigonal Pyramidal because it's a pyramid with a three. The base is three feet, three hydrogens there. And this one is, you describe this as V-shaped. Some people call it bent. I think they do accept bent in the mark schemes, but V-shaped is what I've always used. So that is the vast majority of molecules. If you're thinking about the shape around a central atom, is either one of these three things. Because, why is that? Because most things we think about have 80 electrons in their outer shell. So this covers most of them. So just to summarize that table then, we'll have, so we've got, when you've got four pairs, right, you can either have 4 bond pairs, 0 lone pair, 3 bond pair, 1 lone pair, and 2 bond pair and 2 lone pair. The shape will have the bond angle and we'll have an example molecule. Okay. So the shape for this one is tetrahedral. Green, sorry. This one is going to be a trigonal pyramidal. This one is going to be V-shaped. The bond angle, the basic bond angle is 109.5. This one, the lone pair squashes it a bit down to 107.5 in degrees. And this one, two lone pairs squash it even more down to about 104.5. Good example of this one would be methane. Or you could have carbon CCl4, carbon tetrachloromethane. You could have, getting pretty exotic, you could have silane, but let's think about this one now. 3 lone pairs, 1 lone pair. The example is we could have NH3. An example here, H2o. I'll tell you another little example here. If you draw the dot cross diagram, do you remember the H3O plus ion? That would have that shape because it's got 3 bond pairs, 1 lone pair. H2O, H2S would have the same shape. Very strange things like that we don't really see in aqueous solution. NH2 minus, that's got 2 bond pairs, 2 lone pairs if you want to draw the dot cross diagram. So there is our 3 examples of the shapes of molecule you can get when you've got 4 pairs around the central atom. The rarer ones we'll cover in a later video, but that's that for now.